Hi, I'm Eric Lundin, editor of TPJ, the Tube and Pipe Journal, and host of TPJtv. We're at McCormick Place in Chicago at the FABTECH Expo in the booth at TigerStop to talk to Scott Brodie about cutting efficiency when it comes to tube and pipe.
TigerStop is a linear positioning device, and a number of our customers are already used to doing nesting on their plate stock. What they may not be aware of is you're able to do with a positioner your lineal nesting, which increases your optimization. To start with, what you have is yield. Yield in its simplest form is output over input. So we're all used to creating a cut list, trying to cut for efficiencies, having one length at a time, and stacking them up and then sorting them later. You don't need to do that anymore. What you can do is do what's called a dynamic optimizing. What dynamic optimizing, lineal nesting, allows you to do is give the machine your finished lengths, your cut quantities, which are your knowns. Now what you do is you dynamically take a remnant or a piece of raw stock, tell it what the length is, and it will algorithmically solve for the best fit. It allows you to take a head and tail cut as well as compensating for your saw curves. What I've done here with this machine is to give it an example. Without cutting here, what we're going to do is we're going to actually pick some random length remnant numbers. I'm going to have you, Eric, name a number, and we're going to see how it can nest these parts on our theoretical part.
Okay.
All right. So what I've got here in the unit is I'm going to go ahead and pull up a cut list. Cut list number 99. There can be up to 100 of them here. What it allows me to do is there are inside this cut list, like our customers, they have various lengths they need to cut and various quantities.
Of course.
So dynamic optimizing, unlike standard stock optimizing and lineal nesting, allows you to change the raw material length. The hardest part is to determine what's my best fit out of that raw stock. So Eric, if you would, pick a number at random.
Let's go 12.
Okay, so we're going to enter a 12-inch stock length.
Okay.
Okay, that's very short, Eric. Now, the beauty of lineal nesting, if there's any part in the cut list that can be done, it's immediately going to go there and give us the best fit.
Okay.
If not, it'll tell us the stock's too short. So what it did was, it did tell us there is something in there. So I'm going to go ahead and say, what is it we're going to get? Using our machine, you're able to see it's going to get a 10-inch length out of that 12-inch remnant. A number of our customers, not aware of lineal nesting, would have thrown that 12-inch remnant away. They might have gotten 55 cents a pound for it when they've paid over $2.50 a pound. We are now, by doing lineal nesting, are able to reclaim that material and put it back in use in our production so that we get paid for it. So at this point, what I would do is I would simulate here. I'm going to make this cut, whether it be a bandsaw or a cold saw, and what it's going to do is it now moved in and is going to get that last piece. You'll notice it told me it's an unload position. There are more finished part lengths and quantities that need to be cut for our customers, but now let's have another stock length. Pick another remnant number.
All right, let's go 18 this time.
18 inches. So if there's anything in here that it can process, and it is, you'll notice it immediately went there. My operator is not sorting through the cut list. My operator is not trying to solve for the best fit. Lineal nesting allows you to give it the finished lengths and quantities you get paid for. The unknown is the raw material. You've just picked the raw material and it's there. There's something we can cut. So I'm going to go ahead and start that cycle, and you notice the linear positioner moved right to position. The operator fires the tool, and by goodness, it can get a second part. And if you'll notice right here, this is the amount of waste they're going to have. It is less than ½ of an inch.
Okay.
And again, we can continue on. Why don't we pick a little longer remnant that our customers might have?
All right, let's go with 48 inch.
48 inches. Even better, I can do the 48.5 inch. So I can do a fraction or decimal. It'll move out to the 48.5, and you'll see now it's telling me it's going to get a 20-inch part. I start the cycle just by pressing start. It says I've loaded the material. I'm going to go ahead and fire that tool, and you'll notice now it picked up that 20-inch part, 12.5-inch part. It's now going to get a 10-inch part, and the total waste, Eric, that you see on top if you'll watch, is going to be less than 1 inch.
Less than 1 inch. There it is.
You pick those numbers at random, and that's the key with lineal nesting, dynamic optimizing. Give it the finish lengths and quantities your customers are paying for. Let these machines do the lineal nesting dynamically based on the raw material you have in your hand at that moment.
So you're saving the operator from having to sort through the material and figure out the cut lengths and do the marking. Is that correct?
That's exactly correct.
What's the accuracy on the positioning?
The positioning tolerance on these units are 0.004 of an inch on your position.
How does it keep such a close position?
Well, we use a stainless steel reinforced mesh drive belt. This one is 32 millimeters. In addition, the key is using a closed loop servo-driven unit.
Now you said it also compensates for the kerf of the saw blade, so do you have to input that material before you get started, or that information rather?
Yes, you do. In a push feed mode, when you want a 12-inch or a 13-inch part, you are cutting on the outfeed side of the blade or tool. Now keep in mind, these units can be used on punch presses, drill presses. You can lineal nest any of those materials. But when you are parting the material, you have to compensate for that saw curve. Easily done. Take a piece of material and measure it, put it in your machine and cut it in two. Not in half, but in two. Put the two parts together and measure it. That tells you your saw curve based on the blade runout, your tool runout, and the operator measuring. Easily done.
What do you have for fabricators, though, that aren't ready for lineal nesting or dynamic optimization?
Well, that's a good point, Eric. What you can start with is you still get benefits using just the simple stop. So here we have the saw gear unit. You'll see it's on a cold saw, and we're going to go ahead and make some cuts with it. Now what this allows them to do is have 0 setup time. I'm able to enter a number standing in my work zone, and I can go from 0 to 10 feet in under 5 seconds. My accuracy with this unit is 0.008 of an inch. The other thing it allows me to do is I have 100% accuracy. Eric, it doesn't matter if you punch the numbers or I do, they're going to be exactly in the same position. Not like reading a tape measure this side of the line or that side. The third thing it'll allow us to do is have no rework. We typically, our customers are cutting from long to short, inevitably because they have a missed cut, they're going to go ahead and cut it down to a short size. They still have to go back and get the long length. By having this type of a unit, we don't have that type of rework. We get an increase in productivity because your operator stays in the work zone more, and we do have an improvement in the ultimate material yield. If you recall, yield is output over input. I get more output for less input. I'd like to show you a demo using this saw here, if we may.
Okay, let's take a look.
All right, so what we're gonna do, these type units can be on the left or the right side, and you'll see here I've got a length. So as a go-to stop, for example, I can do 12-inch, 1/16 and press start. So for those customers of ours that are using fractions, they can continue to use those. I can also do a straight decimal, and I didn't have to enter in all 3 digits, it did that for me, straight decimal. Now, this being the entry-level stop for our customers, I can go ahead and create a short list. I can have 10 different moves in here, and I've done that under list number 9. So if you'll see, I'm calling up list number 9, which are a number of distinct different cuts, and I'm gonna go ahead and say, let's start that. You'll see my first cut is 10-inch, and you notice it moved to position. So what I'm gonna do is bring my material up. I'm gonna go ahead and start my saw. And here we go. Let's make sure we're good and clamped at this point. So this is very common what our customers do, and they would normally cut a bunch of these 10-inchers if they're in the cut list. They don't need to do that. To get their efficiency, now that I've created my simple cut list, I press start, and the next length in here happens to be a 15-inch part. I bring my material up, and you notice these are designed to take that type of a shock load. I'm gonna go ahead and clamp it, make another cut. There's my next part. And we'll go ahead one more time. I'll press start, and I've created this cut list. Now I'm out at 50 inches. You'll notice I don't have a 50-inch material here. So I'm going to bring this one up. I'm able to bring it up to the unit. I go ahead and clamp. I'll finish my cut. And the most important thing when we talk about productivity and yield, this part, and this part, and this part is what our customers paid for. That's what we're supplying them. Now let's take a look at what did we have for waste. And then it's important to note, when we look visually and linearly, there is what our customer base paid for. That's what we have for remnants to reuse. So we had 0 setup time, we had 100% accuracy, no rework, increased productivity, and increased yield. Again, for those customers not ready for lineal nesting or dynamic optimizing, they can start with their simple stop the saw gear units and work their way up from there.
For TPJtv, I'm Eric Lundin. Thanks for watching.